The following transformation was made using a matrix, but what is that exactly? Let's say you are given the following equations and you are asked to find x and y. Using algebra, you should probably use either the elimination method or substitution. Now let's say you're given these equations and are asked to find all the variables. Yes, the previous methods work, but that requires a lot more steps. There has to be a better way. And indeed there is. We can form a matrix, which is a rectangular array of numbers which allows you to organize large data sets. Each number inside the matrix are called entries, and the horizontal lines of entries are rows, while the vertical lines are columns. This matrix is an example of a square matrix, meaning that they have the same number of rows and columns, and in this case, it's a 4x4. This is a row matrix, since it only has one row but multiple columns, and this is a column matrix since it only has one column but multiple rows. In most textbooks, this is the definition of a matrix. The position of an entry A is labeled as A subscript MN, where M is the row and N is the column. So this entry is in row 1, column 2. So let's go back to that example. We can arrange the equations into a matrix where each equation becomes a row and the coefficients of each variable line up in columns. We can expand even further and create an augmented matrix, and now we have a fully defined matrix to represent our equations. It is important to note that if an equation does not contain a variable, we treat the coefficient of that variable as 0. Therefore, the corresponding entry in the matrix is 0. So how do we solve these variables? Well, we need to cover more material, unfortunately. Matrices can get a lot more complicated, so follow if you want to see more.